Hello everyone, my name is Logan and welcome back to the lecture hall. Today we're covering section 3.4 of the UCI Math 2A Single Variable Calculus course, the chain rule. First off, I know I've been gone for a while. As I think everyone knows, 2020 has been crazy, to say the least. So let's not worry about that. So what is the chain rule? The chain rule states if g is differentiable at x and f is differentiable at g of x, then big F, which is equal to the composition function f of g of x, which can be rewritten as, f parenthesis g of x, like that. That's a composition function. So then f of g of x is differentiable and f prime of x, big F prime of x, is equal to f prime of g of x times g prime of x. So what is that saying? It's saying that the derivative of our composition function is equal to the derivative of our outside function, with the inside function still inside, times the derivative of our outside function. So that is our chain rule. And then in another way, they have it in the textbook. This is not super important that you need to know, but hey, maybe you see Leibniz notation. Well, it states if y is equal to f of u, the textbook wrote that, not me, and u is equal to g of x, then dy dx is equal to dy du times du dx. Which kind of makes sense because you could be like, oh, the du's cross out. I mean, kind of. So, let's do a problem. So, let's say that we have our function f of x is equal to the square root of x squared plus cosine x. Okay, it looks kind of scary, but it's not going to be that bad. We're going to use chain rule. The first way to start off is I would do what we call a U-Substitution. And what a U-Substitution is, basically, it's just taking your g of x function and letting that be equal to u. So we're going to see, okay, this x squared plus cosine x is on the inside, right? So we get, we could say our u is equal to x squared plus cosine x, and then we could say our function, our f of u, is equal to the square root of u. Okay, perfect. But then what is the derivative of f prime? F of u. Again, textbook notation, not mine. F prime of u is going to be equal to the derivative of f prime of u times u prime. So that's how we do it for these types of questions. We find this derivative and then we multiply it by the inside derivative. Okay, well, perfect. So we need to do this. We have f of u is equal to square root x. Well, square root u. And what is that also equal to? That is also equal to square root, or that is also equal to u to the 1/2. And we see, oh, hey, perfect. Power rule. So we subtract 1 and we bring this 1/2 out front, and then we get that our derivative, f prime of u, is going to be equal to 1 over, because we have u to the 1/2, right? Because that would be equal to 1/2 u to the negative 1/2, and that is equivalent to this. And this is also equal to 1 over square root u. Oop, I dropped the 1/2. So, that's our f prime of u. But now we need to define the derivative of u. So, u is equal to x squared plus cosine x. But, what's our derivative? Well, we just, ddx on both sides. And we get u prime is equal to, well, x squared, power rule, 2 comes in front, minus 1, 2x. Plus, well, what's our derivative of cosine? Well, remember, so it goes sine, cosine, negative sine, negative cosine, sine, cosine, and it keeps going on and on. So we know, okay, we get rid of this plus, and it's just minus cosine of x, not minus sine of x, sorry, yikes. Okay, so now let's put it all together, because we have our f prime of u, and then we have our u prime, and then every time we see this u, we're going to substitute our x squared plus cosine x back in. So we get that f prime of x is equal to, well, we get 1 over 2 times the square root of u, well, what's u? X squared plus cosine x, times 2x minus sine x. Right? And then so we can just kind of rewrite that to be 2x minus sine x over 2 times the square root of x squared plus cosine x. And that is how you do the chain rule for the most part. Alright, let's do a trig example. So what if we had f of x is equal to sine of x to the fourth? Well, we do our U-Substitution, and then we get u is equal to x to the fourth. And so now we have f of u is equal to sine of u. So then we know f prime of u is going to be equal to the derivative of sine of u times the derivative of u, or u prime. So what's u prime? Just because that one's really easy to find, u prime is equal to, well, power rule, 4 comes out front, minus 1, 4x cubed. So now we just need to find the derivative of sine. Well, we know the derivative of sine is cosine, so we get that f prime of u is equal to cosine of u times u prime, and now we just plug in our u and u prime in, and we get f of x is equal to cosine of x to the fourth times 4x cubed. So that is how we would do it, chain rule for trig functions. Now we're going on to the general power rule, and it states, if n is any real number, and u is equal to g of x, and g of x is differentiable, then d dx of u to the n is equal to n times u to the n minus 1 times u prime. And that's the same thing as saying the derivative of g of x to the n is equal to n times g of x to the n minus 1 power times g prime of x. So that's our general power rule. And if you can get that down, it'll be, usually you can get through those questions pretty quick. So, now we are going to cover exponential functions. Let's just say we had a function, something like d dx of b to the x, where b is any real number. Our derivative of b to the x is going to be equal to b to the x times ln of b. And so maybe a few of you are like, oh, so that's where e to the x comes from. Or y, and we'll get there. So, we have e to the x. And if we take the derivative, d dx of e to the x, we know is equal to e to the x from before, from previous videos. But why is that? I thought it was b to the x times ln of b. Well, if we were to do it, so it's e to the x times ln of b of e. Well, what is ln of e? That is equal to e to the x times log e to the e, right? And then we should probably see, okay, when this number and this number are the same, we are going to get that that equals 1. So then we just get this is equal to e to the x times 1, which is just, well, e to the x. And that is why the derivative of e to the x is just e to the x. The great thing about the chain rule is that it can be extended to many composition functions. It doesn't just have to be an f of g of x. It can be an f of g of h of x, or it can be an f of g of h of j of k of x, or something. It can be extended to as many functions as you'd like. So, if we were to say we have big F of x is equal to f of g of h of x, what's its derivative? Well, it's just going to be outer, the derivative of the outer, with the inner still inside. So, f prime of g of h of x times, well, the next function, like the second one, the next most outer, then it's going to be g prime of h of x. And now, because there's only 3, now it's the times the inner, the derivative of the inner, so it's times h prime of x. So that's how you would do it for, say, 3 functions, and you just follow the pattern for 4 functions and whatever and beyond. So that's all well and good. And this is all that I have for the lecture portion of the video. Let's transition into some practice questions. Okay, for the questions, we're going to be doing number 8 and 31. These are 2 pretty good problems, or at least I think they are. So let's start. F of x is equal to 1 plus x squared to the 99th power. Well, we know the general strategy for power rule because I gave you the formula, and we know that it's going to be just power rule, so bring the 99 out front, 99 out front, times 1 plus x squared to the 99 minus 1, 98, times the derivative of what's on the inside. Well, what's the derivative of 1 plus x squared? Derivative of 1, 0. Derivative of x, 1. Derivative of x squared, 2x. So then we get that that is equal to 1 plus 2x. And that would be how to solve this one. This one's a really quick one because we have our general power rule strategy. Alright, this next one, number 31, is a really good one because we have to use the product rule. I don't know why I couldn't remember the name. But we have to use the chain rule and the product rule. So let's start. We know that if we take this to be our u, this u is equal to t sine 2t. We know that f prime of t, or if f of u is equal to e to the u, we know f of u, f prime of u, is equal to e to the u, because it's just, exponential e function, times u prime. Well, then that's not too bad. Then we're almost done. But we need to find u prime. Well, u is equal to t times sine 2t, so that means u prime is going to be the product rule. And then let's just do the product rule. First, the last. T times the derivative of sine 2t. Well, what's the derivative of sine? It's cosine. So we keep the cosine 2t. And then we're like, hey, wait. This 2t is a function inside of the cosine function. So we have to also multiply by the derivative of 2. And then now we add last d first. Well, what's the derivative of t? 1. And then it's just 1 times sine 2t. So then we get that our u prime is equal to 2t cosine 2t plus sine 2t. And then we can just write it all out, plug in our u's and u primes. We get f of t is equal to e to this t sine 2t times t 2t cosine 2t plus sine 2t. And that is how you would do this problem. So, these are all the problems I wanted to cover today. There will be more problems in the suggested homework, there will be suggested homework in the description of the video. My name was Logan. Thanks for watching. Have a great day.